That's done. Now, the rest of this workbook is code that I've written for you to try and visualize what's going on. So here we are going to choose just the results from our grid for alpha equals 0.99, which is very close to L1 regression, the lasso. Here you can see all the results. Overall, actually, this is looking like a fairly decent model, even for a relatively high level of penalization. We've got a good model, performance improves. If we look, for example, at the validation performance, it goes down to about just under 14,000 before getting worse as the model is overfit. I've written some code here to graph that performance, and you can see on train performance continues getting better and better, showing that it's overfitting. On validation, the performance gets better. The distance between these two curves widens as overfitting really starts to hit, and some point over here, the validation performance actually gets worse as the model gets too complicated and is just fitting noise on our training data, and so when it predicts on the validation data, it's predicting inaccurately. Now, how do we view these results in 2 dimensions across the whole grid? Well, I'm sure there's some lovely packages out there that do that. Here's some code that I tried to write. I can't say this is particularly sensible code. I was struggling to get a 2-dimensional representation. If anybody can do something pretty with contours or whatever, which is nice and continuous, I'd love them to submit some code on Moodle. We've got 3 values of alpha. We have alpha equals 1, more or less, which, well, 0.99, which is our lasso. We have alpha equals 0, which is our ridge regression, and alpha somewhere in the middle, which is the elastic net. The yellows and the greens are the poor performance. Anything dark is the best performance. And you can see that for each of these models, there is a best point for some value of lambda. You can't really see, unfortunately, from this fairly pathetic representation which one is best. So I tried something slightly different. Now, what we can see here is interesting. Let's start with our ridge regression, which is the one up here. The orange line is the validation performance, which goes down and then starts to go up right at the end when the model gets too complicated. And the dotted blue line is the train performance. You can see that at the maximum performance on validation, there's quite a gap between the orange and the blue dotted lines. The best performance on the red line is about the same as the orange. So using ElasticNet hasn't given us better performance on validation. And the green line is everywhere below the red line, especially where we have best performance. So in terms of overfitting, it looks like ElasticNet is slightly more overfitted at the best point. The lasso model, well, again, it's hard to tell from this graphic, but it looks like this brown line over here does reach lower than either the orange or red, which means the lasso model is actually providing the best model